So if you found question number one really easy because you were just making one side look like the other without actually doing a whole lot of calculations, I think you'll find that question number two is equally satisfying because it's really another question just like number one in disguise. In question number two, it says 2 to the power of x plus 3 equals 16. And you might be saying, well, Herbert, that doesn't look like number one. That doesn't look as easy. So think about what made number one easy in the first place. When you did the exponent or the solving, you were really just looking at the exponent and comparing the exponents themselves because the bases were already a match. 5 and 5 in letter A, they were already matching. You didn't have to make an extra step to think about what makes those look the same on both sides. In letter B, you had a base of 2, base of 2. Letter C, base of 3, base of 3. Letter D, base of 4, base of 4. I mean, most of us probably didn't even notice the bases because we were so focused on the exponent, knowing that that was the part we had to think about. So in question letter A, it says, how can you rewrite the equation to make it easier to solve, like those in number one? And I think we should acknowledge here that it was the fact that they had a common base on both sides that made each problem in number one so doable. So let's think about this. How could we make this problem look like two exponential expressions with the same base? The left-hand side is already an exponential expression, so I'm not inclined to change that. It seems like 2 to the power of x plus 3 is fine. So the question is, can we write 16 as 2 to the power of something? So that would be the question, is can we make it look equivalent? And if you notice that the number 16 is indeed a power of 2, then I think you'll find that all of a sudden this question is going to look a whole lot different with a quick rewrite. If I keep 2 to the power of x plus 3 on the left and change 16 to 2 to the power of 4, which doesn't actually change the number itself, it just changes the way the number looks, but that doesn't really matter. 2 to the 4th is still 16. I haven't changed the equation at all, but now hopefully you're looking at this problem and saying, oh, this is just as easy as the first one. Something plus 3 is going to have to match 4. Obviously that something is going to have to be 1. Now, of course, you could do a little bit more formality if you want to. You could say x plus 3 on the left-hand side equals 4, and you could solve algebraically, like a little equation, to figure out what the right answer for x is. But if you're one of those people who can just kind of look at an equation and intuit the right answer, I would definitely do that. Now in letter C it says plug in the solution and verify that it does indeed satisfy the original equation. So we should do that. 2 to the power of, now instead of x we solved 1 plus 3 equals 16. And I just want to check 2 to the power of 1 plus 3 is 4. And yep, that is true. 2 to the power of 4 is 16. Everything checks out. So in theory, if we can change the problem so that we can get ourselves to the point where we can see a common base on both sides and then focus our energy on the exponents, it looks like we can do the same common sense approach. So make sure this idea makes sense. And if you have a chance, try question number 3. If you don't feel too confident in number 3, in the next example I'll give you a couple, or the next video, I'll give you a couple more examples so that you can follow along.